Good morning students, myself Ms.Logeshwari from G.K.jain Higher Secondary School. Students, today I am going to teach about properties of set operations from 9th standard mathematics. Students, by previous classes we know that what are the properties of set operation, isn't it? The first property is commutative property. Then second main property is associative property. Yes, commutative property and associative property. By today's session we have to see distributive properties, one of the very important and easy property to you. Okay, my topic is properties of set operation. Properties of set operation. What is meant by set operation? Set operation means intersection and the union. Intersection and the union, which means set operation. There are two types of set operation. The first one, intersection, and second one is union. So properties of set operation over intersection over union. Okay. By your lower classes already you know that distributive property, isn't it? What is meant by distributive property? Or multiplication over addition. This is your distributive property. By your 6th and 7th classes, you know that A into B plus C is equal to A into B plus A into C. This is your distributive property, multiplication over addition. Okay, but subtraction is not satisfied in your distributive property. Addition only satisfied distributive property. Okay, in the same way, distributive property of set operation. Okay, that's the thing. Okay, now suppose for example A is equal to 1, B is equal to 2, C is equal to 4. Substituting we get A 1 into 2 plus 4 is equal to, this is your LHS, and RHS will be A into 1, which means 1 into 2, 2 plus A into C will be 4. So 1 into 2 plus 4 is 6 is equal to 6. 6 equal to 6, which means LHS equal to RHS. This is your distributive property of whole numbers, rational numbers, whatever, but this is your lower class concept of your lower classes. Okay, but my question is properties of set operation. Okay, properties of set operations over union and the intersection. Okay, so first thing, this is your distributive property. Distributive property of sets. Distributive properties of sets. Suppose we take any three sets, A, B and C. The notation of set should be in capital letters of your alphabet. Okay, already you know that the notation. Yes, distributive property of set. Suppose we take any three sets, A, B and C. Okay, capital A, capital B and capital C be three sets. Okay, so first classification is A union B intersection C is equal to, union will be distributed both the terms A union B intersection A union C. This is your first classification of distributive property. This is nothing but union. Union is a first term. Yes, so over union operator. This is your first classification. Then second classification is A intersection the other way. The first one is union. Obviously second classification will be intersection. So A intersection B union C is equal to A intersection B, then union A intersection C. This is over intersection. This is your second classification of distributive property of sets. So this is your first formula and this is your second formula. Students, by previous properties we have checked into, one way is element based and next one is Venn diagram based. Okay, so first we have to verify element based. Okay, this is your first result. So now we have to check the first result based on elements. Okay, suppose we take the elements of the set A is equal to 2, 4, 5, 6, 7. Okay, the set of all the elements of B. Okay, now B is equal to 5, 6, 7, 2 and the 0. This is your all the elements of B. Then C is equal to 5, 7, 2, 10. This is your all the elements of set C. Okay, now we have to verify the first result. First, that is your first distributive property. The first distributive property here, LHS is A union B intersection C, isn't it? So LHS is equal to A union B intersection C. First you should find B intersection C. Then only you have to verify the whole thing. Okay. So B intersection C is equal to B intersection C is nothing but what? Common element of both the sets. Common element of both the sets. What are the common elements of both the sets here? Consider your set of all the elements of B and set of all the elements of C. Okay, consider both the sets. Okay, what are the common elements of both the sets? 5, yes, 5, 5, then 7 and 2, 5, 7, 2. This is your common element of both the set B and the C. Yes, 5, 7, 2. Because of 5, 7, 2 lies in both the sets. Okay. Then after that, you have to verify A union B intersection C. Already you know that the concept union, joining both the elements of A and the B intersection C. Yes, what are the elements of A here? 2, 4, 5, 6 and 7. Joining with B intersection C. This is 5, 7, 2. Okay, joining all the elements. Finally, we have repeated element. Repeated element is impossible. Okay, so 2, 4, 5, 6, 7. This is your A union B intersection C. Okay, 2, 4, 5, 6 and 7. This is your first equation of distributive property, which means this is your LHS. Okay, now we have to verify RHS. A union B intersection, A union C. First, A union B. A union B means, already you know that students, all the elements of A and B. So, all the elements of A and B. So, all the elements. So, 2, 4, 6, 5, 6, 2, 7, 0. This is your all the elements of joining A and B. 2, 4, 5, 6, 7 and repeated element not consider students. So should not consider repeated elements. So that's why we can written 2, 4, 5, 6, 2, 7 and 0. This is your A union. And A union C. Okay. After then only you have to verify common elements of both the sets. A union C. Okay. Joining all the elements of A and C. 2, 4, 5, 6, 7, 10. 2, 4, 5, 6, 7 and 10. This is your A union B. Okay. Now we have to verify A union B intersection A union C. That is your common element of A union B and the A union C. Okay. This is your RHS. This is your RHS. Okay. Now we have to verify this term. Okay. A union B intersection A union C. What are the elements? 2, 4, 5, 6, 7. This is your common element. This is your second equation, or this is nothing but your RHS. Okay, now you see equation 1 and 2. Consider equation 1 and 2. Yes, LHS equal to 2, 4, 5, 6, 7. 2, 4, 5, 6, 7. Equation 1 is equal to equation 2, which means LHS is equal to RHS. So, distributive property of set operation having the first classification is verified. Okay, by 1 and 2 we get LHS equal to RHS, which means A union B intersection C is equal to A union B intersection A union C. This is your first classification. So your first classification is verified by elements, based on elements. Okay, next possibilities is Venn diagram. Yes, obviously Venn diagram. Already you know that, students. Venn is one of the British mathematicians, isn't it? Okay. Yes, Venn diagram. Second classification is A intersection B union C is equal to A intersection B union A intersection C. Sorry, A intersection C. This is your second classification to verify by using Venn diagram. Okay, Venn diagram. By using Venn diagram. A intersection B union A intersection C. Okay, first to verify LHS. Your LHS will be, there are 3 sets are given, isn't it? So the 3 circles, we should draw the 3 circles. 3 circles mean 3 sets, A, B and C. Okay. So A, first you should find B union C. Then only you have to find 4 things. Okay. B union C. So all the portions will be shaded. All the regions of B and C will be shaded. This is your B union C. Okay. Then A intersection of, this is your B union C and this is your A intersection B union C. Okay. So B union C, A, the intersection, that is the common region of A and B union C, which means the common portion of A, that is the circle of A and this diagram. Okay. So common element A and this portion. This portion only the common portion of that expression, isn't it? This portion only the common element of A intersection B union C. Okay, and this is your LHS. This is your first equation, first diagram. Okay, then to verify your RHS, okay, first you should find A intersection A, B and C. This is your A, B and C. This is your A intersection. Okay, what is your common region between A and B? Here, this is only the common region between A and B, isn't it? The common portion between A and B circle. Okay, this is your A intersection. And next one, A intersection C. A, B and C. Okay, the common portion between A intersect A and C. So this is your common portion between A and C. Okay, this is your common portion. This is your common portion between A and C. Okay, now we have to find A intersection B union A intersection C. Finally, we have the set A and B. The last one is C. So this is your A intersection B union A intersection C. So joining both the diagram, that is combined together, combine both the diagram, finally we have this portion will be shaded, and this is your second diagram, second equation or second diagram, that is combine both the diagram we get, that is combine means here union, joining with both the diagram, finally we have this diagram. So see your equation 1 and equation 2, 1 equal to 2, both the diagrams are same. Yes, so this is nothing but distributive property. By 1 and 2 we get distributive property is verified by using Venn diagram. This is your second way to verify your distributive property. Okay,